Okay, let's see if this works. So this is basic properties of logarithms. There's the log of 1 and the log of a. We already know that the a and the a cancel each other out. And then log a of 1 equals 0. That's always going to be true. Now the product rule says when you take two logs that are being added together and they have the same base, that a, then you can rewrite it as a single log with those two values multiplied together. And then the quotient rule, of course, is if you're subtracting two logs, then you can create a fraction and write it as a single log. The power rule just says if the thing inside the log has a power, you can take that power and move it out in front. This one says to use a calculator to evaluate each pair of expressions. Then state which rule of logarithms this calculation illustrates. I'm not going to do the values. You can do the values, but this one would be the power rule. I'm sorry, the product rule. This one is the quotient rule. And this one is the power rule. Okay, let's try some of these. We're going to expand. Each of these formulas up here that we went over, they work both ways. So if you're given this, you can rewrite it as that. So they go both ways. So this one, we have the natural log of k times z. So I'm going to rewrite it as the natural log of k plus the natural log of z. Okay, for b, this one is a fraction, so that means I'm going to subtract them. I'm going to have log base 2 of x minus log base 2 of z. So what this does is it sets up kind of a method you can use to remember which ones go in the denominator or not. You always look at the sign in front of the log. So for the x, the sign in front of the log, there's nothing written, so we assume it to be a positive, so he's on top. Now the z is a minus out in front of the log, so he is on the bottom. It's all about what sign is out in front of the log. Okay, this one's got this guy, so let's rewrite him. The square root of x cubed can be written as x to a fractional power. The 3 goes on top. The square root is a 2, so the 2 goes on bottom. So it's x to the 3/2. So log of x to the 3/2 over k. I'm going to rewrite it as a subtraction. Minus log of k. And then I'm going to move that power out in front. So it'll look like this. 3/2 log of x minus log of k. And that would be that one expanded. Okay, this one, we've got a 4 and a y cubed, so I'm going to give each of those their own log. And it's a plus because they're being multiplied. Okay, this 3 can bump out in front. And this one over here, log base 2 of 4, if you were to plug that in the calculator, it kicks out 2. So let's just write it as 2. Okay, b right here, this z is going to be z to the 1/2 because it's the square root. We're going to write 3 different logs. We have the ln of x plus the ln of y cubed minus the ln of z to the 1/2. And then I'm going to move the powers out in front. So final answer is ln of x plus 3 ln of y minus 1/2 ln of z. Okay, C looks a little bit different, but just because it's got 2x plus 1 and x plus 2 being raised to the powers or the square root, it doesn't matter. That's just going to be what goes into the log. So square root of 2x plus 1 is actually 2x plus 1 to the 1/2. So I'm going to write it like that. Log of 2x plus 1 to the 1/2 minus, because it's a fraction, log of x plus 2 squared. Okay, I'm going to move the powers out in front. So I have 1/2 log of 2x plus 1 minus 2 log of x plus 2. And that's as far as you can take it. You can't distribute a log into a set of parentheses. Logs don't work that way. So you would stop right there. Okay, example 4 says the equation y equals b times x to the a used in application. Another form of this equation is y equals blah, blah, blah. Use properties of logarithms to obtain the second equation from the first. Okay, so we've got y equals, we don't need the y. We're just writing it as a log. So the log of bx to the a, that's going to be log of b plus log of x to the a with the power out front. We get log of b plus a log of x. Done. Okay, these next examples want you to condense them back down. So write it as a single log. So we're going backwards of what we've done before. This is a plus, so that means we're going to multiply them. I write it as one natural log, and then 4e squared times 3e to the negative 2. These e's are going to cancel out. If you add their powers together, that's just 0. So we would just multiply the 4 and the 3 together, and we would get ln of 12. Okay, the next one's another plus, so we're going to multiply it together. 4x times 2x, that would be log of 8x squared. And we're condensing, so we don't need to move any powers or anything. Okay, this one's a minus, so it's going to be a divide, a fraction. We're going to go log base 2 of x to the 4th over x. X to the 4th over x, though, that's going to reduce down just to x cubed. Okay, same thing. Now this one's got multiple expressions in it. That's fine. So I'm going to write a single log. The 6 and the 3 are being plus together, so they get multiplied. But the 9, he's subtracted, so he's going to be divided. So that's the log of 18 over 9, which is the log of 2. Okay, for this one, I see numbers out in front. Those are powers, so I'm going to move the powers up first. When you are expanding, so you take a single log and you write it as multiple logs, the power comes last. But when you're condensing, you're taking a big, like multiple logs, and you're squishing them into one log, then powers come first. So this will be ln of x to the 4th minus ln y to the 1/3 plus ln z to the 1/2. Now I can do each of those fractional powers as a radical. Okay, let's put them in their spot. So we've got 1 ln now. X to the 4th has a positive out in front of the log, so he's going to go in the top. The cubed root of y has a negative out in front of his log, so he's going to go into the bottom. Z has a positive in front of the log, so he's going to go in the top. Okay, this one looks like I have one power to move up. Oh, there's one. So log base 5 of x to the 6th plus log base 5 of 4x minus log base 5 of z to the 3/2. Okay, putting it as a single log. Well, actually we can rewrite z first. So this guy is going to be a square root because of the 2, and underneath the square root is going to be z to the 3rd. So rewriting it, log base 5, x to the 6th, that's a positive log, so it stays on top. 4x, positive log, so we're going to multiply it in the top, and then square root of z cubed will go in the bottom because it's subtraction. And then the last thing is to join those on top. That'll be log, let me scoot that over. So final answer will be log base 5 of 4x to the 7th over square root of z cubed. Okay, next one says simplify log base 9 of, square root of 3 to the 3x power and find the domain of f. Write your answer in interval notation. Okay, so first thing we need to make sure is that the square root of 3 to the 3x is going to always be greater than or equal to 0. So the only problem we have is when we have a negative underneath here. We can get rid of the square root. So 3 to the negative 3x. Are there any numbers that you could plug in for x that would turn that into a negative number? There's no numbers. Even if you plug in a negative number for x, that doesn't change the value of the base, this guy 3 right here. So this has no restrictions. Your domain is going to be all real numbers. And it says to simplify that, but there's not really a lot you can do to simplify that. I guess we can write it as 3 to the 3x to the 1/2 power log base 9. So it would become log base 9 of 3 to the 3x over 2. But that didn't really simplify it. So anyways, that's good enough right there. This one says use a calculator to approximate each expression to the nearest thousandth. So on your calculator, I should have told you this on the other screen, but on your calculator, there is a log base button for when the base is something other than 10. It's under the math menu. It's at the very bottom. It's called log base. Not sure if we went over that yesterday. So this one comes out to be about 1.951. And then, oops. Log base 2 of 6 minus log base 2 of 150. That's negative 4.644. Okay, that's it.